Hey everybody, this is Larry. This is day 28 of the Leetcode Daily Challenge. Uh, hit the like button, hit the subscribe button, let me know what you think, and let's get to it. Counting bits. Give a non-negative integer number num. For every number I in the range I between 0 to num, calculate the number of ones in the binary representation and return them as an array. Okay. Okay. Do it without the building up. I guess that makes sense. Otherwise, just go straight forward. I guess these are follow-up. Okay. So I think the naive algorithm is just going through each number and then counting, which I think this is actually what this is saying. But can you do in linear time, possibly in a single pass? Um, and I think you can, based off the fact that it's similar to dynamic programming, which is that the number of ones in a number is equal to the number of ones of the smallest bit divided by 2, right? So what I mean by that is let's say you're given a number, I don't know, that's a terrible number. Let's say 22, I don't know. And binary, it's 16 plus 4 plus 2, right? So that's equal to 1, 0, 1, 0, 1, something like that. And that is just equal to the last digit, which is 0 in this case. So that's just 0 plus f of 11, right? Because here, you already know the answer, or in this case, you would have already calculated from 0 to num as a prefix. So I think if you do that, then you only need to do one operation for each number, which is, well, I mean, two operations, I guess, but like constant amount of operation, which is just check the last number and then divide it by 2. I think from that we can get started real quick. And we'll talk about complexity later and the follow-ups, but that's how I think my strategy is going to go, because versus the naive algorithm where you, given 22, you would go 1, 2, 3, 4, 5, and just count one at a time, right? Cool. Yeah, okay. So now let's go. I have to include 0, okay. So it's for x in range from 0 to num plus 1, or to nums, but this is exclusive, so, right, yeah, okay. And now we also want, let's just say it. I want to call it DPOA, but maybe everyone calls everything DPOA. Let's just go answer array then, which is, let's just say 0 times num plus 1. This is just to create an array of that size. And then now we can just set answer of x is equal to answer of x mod 2, which just counts the last bit to see if it was a 1, plus answer of x divided by 2. And in Python, this is the integer division. Just to be clear. Just want to create more space. Okay. So I think that's kind of it. But I think the little weird case here is that if x is equal to 0, it adds itself, which in theory is already 0, but it's still like a weird case. But I think it should be okay. I think, okay, let's just make it clear by starting from 1, and then we don't have, I was almost going to do something like this, but this is already true from this statement. But I'll leave it in here just for clarity, though I know that I don't need it per se. Okay, let's try the example cases and run it real quick. So it's a little slow right now, isn't it? What is n up to? I guess it doesn't say, so but I'll also just try a big number. Can n equal to 0? It's not clear, but try a bigger number, but not that big because you're still constrained by memory, so it's probably not that big in either case. But worth trying. It's for free, except for apparently penning is a little slow. I think it's also low slow too. Output limit exceeded. Okay, I guess that's fair. I guess this is too big of an array. Okay, fine. Let's just remove it and then try again real quick just to make sure. A little bit weird, but I think the answer seems to be mostly right, so I'm just going to submit after this. If it's right, of course. If it's incorrect, then it would be silly to do that. But yeah, okay, cool. So submission, it works. Um, yeah, how to, so there are a couple of things to go over for this problem. The first is, well, let's take a look at the hints to see where they want us to do. She should make a, yeah, okay, that makes sense. And that's what we did. Divide the number in ranges and so forth. I guess we actually, I think we just did the dynamic programming, but okay. Maybe that's a hint for that. For me, it doesn't really help. So complexity, right? I think this is a problem. It's that it's a little weird in that you can analyze this complexity in a number of different ways, and depending on how you want to analyze it and what kind of variables you're optimizing for, But I'm gonna go over each of what I mean by that statement. First of all, given that n is this input number n, and there's some ambiguity with respect to what O of n means, especially since in this case you want to say that the n is the input number, but usually by convention n is the number or like the input size, which is sometimes the number of bits that is an input, which in this case is an int, so it's like 32 bits, right? So n in this case is technically 32, or for n something less than 32, depending on how you want to define your ints. But that said, so you can think of analyzing your complexity that way, and sometimes you do, and actually often you do in academics. But in this case, just for the sense of clarity, I'm going to use n is equal to the number, the actual number, not the input size of the number. So yeah, clearly we look at each loop once. So this is O of n, and this is a hard O of n, and in the sense that it is a strict O of one space. Oh, sorry, O of one. For each of the n elements, you do O of one work. So total, it is O of n running time. And space, it's easier to figure out. There's one element for each space, so this is O of n space, right? And why do I say like that? Because I try to be very particular in my language, because this is a little bit trickier problem in terms of analysis if you want to be really pedantic and you want to be really correct. And what do I mean by that? What I mean by that is that in a parallel world, you can use, there's like other, I think there's a bit count in Python too, but let's say we have some code that was like, okay, answer of x is equal to this of x, right? But what is the complexity of this? Well, can we assume this is O of one? I guess it depends on the context. And what I mean by that is that in a lot of times, and in a lot of forums or conversations, people will assume stuff like this is O of one, but it also depends on the size of your universe, right? And if you want to use the notation U being the size of your universe, and in this case, the size of universe is related to your input size, again, a tricky complexity. But what I mean by that is that the input size is the number of bits, then this will take O of the number of bits, right? Which is also log U in this case, but because it takes log U bits to represent this U, where U is the size of the universe. In any case, you can say that that's a constant because it's like, if it's a 32-bit int, then it's just 32 times, and 32 times is O of 1, right? But it depends on who you talk to and who you want to, what kind of optimization you're talking about. And also for this particular problem, why I bring it up is that in that case, this is also O of n and also O of n space. So then you may ask, why are they different? Well, this is a problem where that constant, which may not be a constant, actually matter, right? Because here, let's just say for the sake of argument, it does, things like this is actually hyper-optimized, and they're bitwise operations and stuff like that. So that is actually not as drastic as I will represent it, just as a disclaimer. But let's just say for the sake of argument that it takes, there's a for loop, it just does one bit at a time, and it takes 32 operations, right? Well, here, it only takes one-ish operation plus another operation for adding and a memory lookup. You can figure out how let's just say it's 3 or 4 operations. Again, there's a lot of nuance. All the operations are not the same in terms of cost. Some cost more, some cost less, and so forth, right? Memory lookup, for example, is more expensive, but but just to kind of give you an idea of why we're doing this instead, is that this gives us really back of the envelope 8-time speed up, right? So I'm making it more rosy, and it probably isn't that high of a speed up, but that is why we would want to do something like that. Um, in any case, so it is a sort. The way that I thought about it, I don't know about these hints, but the way that I was thinking about it immediately was just dynamic programming. And the thing that I was thinking, my thinking process was actually exactly like the hint, which is, well, I mean, dynamic programming, I know it's a big word I used before, but also I think this one was the one that I saw relatively quickly, I suppose, where I was like, okay, we just have to look at one bit at a time. And what does that mean? Well, when I look at that one bit, and then we could not think about that bit anymore, right? Then when we not think about that bit anymore, then what is this number that we're trying to care about? Well, it's just 11 because it's just divided by 2. And then now we have a recurrence that is this bit. Now, of course, this is true. There are a couple of things. Right? One is that this is true even in a very general case, except for that it would, maybe a little bit more expensive because then for each bit, you're looking up another array element and you're doing a recursion or something like that, depending on how you want to do it. But in this case, because this problem asks you to already calculate from 0 to num, you can jump right ahead because you're already going to, for every answer here, you're already going to return it, you're already going to need it. So in this case, it's a much easier consideration for that reason. And also, it is the beginning of what I would say, like a beginner's way of just being like, hey, this is a memorization problem or a dynamic programming problem, right? And you should use the results that you already calculated. Cool. So in terms of interviewing and competitive programming, I think this is straightforward. So definitely recommend practicing, especially even though this is not. I don't know if it's a strict dynamic programming per se because I don't know. I think the term has kind of been diluted a little bit over time. Everyone calls any reusing of calculations dynamic programming, but it does share the same mental framework and kind of like, okay, let me try to think of given a problem, think of itself as a smaller version of itself, right? Smaller problem that we can solve, and then keep on doing it recursively, kind of. And then from that, we can get the answer. And then that's a good philosophy to have in general to attack actual tougher dynamic programming problems without just thinking of patterns. Because I think the other thing that I get a little bit that I rant about is that dynamic programming has become this thing where everyone just memorizes patterns or for an LRU cache on it. But if, practice it. I recommend it. It's a cute problem, and it's a good intro problem as well. I believe that. Cool. Let me know how you did it. Let me know what you think about this problem. Did you solve it okay? Did it take a long time? Was it good? Hit the like button. Leave a comment. Would love to hear from you. And I will see y'all tomorrow. Bye bye.